I realize resistivity isn't the easiest concept to wrap our mind around, so I thought some problems might help. I want you to imagine a wire made of copper and a wire made of gold. Notice the copper has a lower resistivity, 1.72 times 10 to the minus 8th versus 2.44 times 10 to the minus 8th. Which material is a better conductor? Copper is a better conductor. It's got a lower resistivity. Is a copper wire always better than a gold wire? No. Copper and gold can have whatever kind of resistance they want based on the shape and size of the wire. Resistance is not the same thing as resistivity. Just keep that in mind going forward. If you look at this table, you'll see the resistivities of several common materials we'll use in this section. On the left-hand side, you'll see several materials that are known to be good conductors. Copper, gold, silver, and so on. They have very low resistivities, times 10 to the minus 8th. On the right-hand side, you'll see some materials with very large resistivities. Rubber is well known, Teflon, wood, very high, times 10 to the 10th, 16th, and so on.
The resistivity of dinosaurs is currently unknown.
A common material used in the heating elements of space heaters is a nickel-chromium alloy, where this particular alloy we're going to deal with is 100 times 10 to the minus 8th ohm meters in resistivity. Let's say it's 2 meters long, has a cross-sectional area of 0.008 square meters, and an aluminum wire. And they've got the same resistance and the same radius. How long is the aluminum wire? Well, what we can say is, remember, resistance is rho L over A. We can find the resistance of the nichrome is equal to 100 times 10 to the minus 8th times the 2 meter length times divided by the area, 008. So the resistance of that is 2.5 times 10 to the minus 4th ohms. Be careful. So now the question is, how long would an aluminum wire have to be so that they have the same resistance? Well, we know rho for aluminum. We're looking for L. 0.008 meters squared. I get 70.9 meters. What if we touch a gold wire to a 10-volt battery? Let's assume it has a 2 millimeter radius and allows 30 amps to pass through it. How long is the wire? New stuff going on here. We have volts and amps, so we're going to have to deal with V equals IR for our 10-volt difference from front to back with 30 amps passing through it. Gives me a resistance of 3.3 repeating ohms. Okay, that lets me work with something. 3.3 repeating equals rho, and we have rho from a previous problem. You can always go back and look at the chart that I gave you at the beginning of this video. It's also on Canvas. Now radius, I gave you radius, we need area. So we got to deal with pi r squared. I get a length of 172 meters. Alright. Well, now let's try this with something you'll encounter in daily life. Let's say there's a dinosaur that narrowly avoids getting hit by a strike of lightning. So, Lightning, it turns out, is generally between clouds and ground, has a difference of about 67 million volts. And we're going to deal with a height of 22 meters. That's about a 7-story building. So rho for air in this situation turns out to be about 0.2 ohm meters. That's a lot bigger than you would expect, but actually it's a lot smaller than air normally is. Lightning does weird things. A lightning bolt generally has a radius of about a centimeter, or about an inch, which comes out to 0.025 meters. So my question is, how much current is there? That's a big deal. Current, voltage, we know we're going to have to deal with V equals IR, but we don't have R. So we got to find R first. R is rho L over A. So we find the rho times L over the area, again, pi R squared, I get a resistance of about 2,241 ohms. If we plug that into that difference, that's 67 million volts. I times R. I get a current 29,900 amps. That's enough to deliver 15 coulombs of charge in 30 microseconds. That's a teeny tiny amount of time for a huge amount of charge. You to try. If I plug a light bulb into an outlet, it'll have 120 volts across it. The filament inside that light bulb is about 58 centimeters long and has a diameter of about 46 micrometers, 0.046 millimeters. When plugged in, it has 0.06 amps running through it. My question is, what is the resistivity of this material? And, using that chart, what material is this most likely? If you have a copper wire, and then a second copper wire, with double the length, and double the area, the radius, which one has more resistance? Or are they the same?